want to welcome our webinar guests to KIRKS Toolbox webinar, Protect Your DPF with Idle Reduction and Troubleshooting Tips with RoadWarrior. Our panelists are Bob Kirkman. He is the co-president of KIRKS, and he's been in the transit parts industry for over 25 years. Dave Jerman is the sales director at RoadWarrior. Dave is an industry expert with 18 years of experience in the catalyst and exhaust after treatment system technology field. I'm Linda Kleist, acting as your host, and Abby Thompson is back on technical. If you have any technical issues, please let us know in the chat and we'll be able to respond to you there. Dave and Bob also want to answer your questions, and we'll have that at 2:45. You can type your questions in the Q&A in your toolbar, and we'll be collecting those. And then Dave, we are looking forward to learning more about how our DPF and after treatment system works and how RoadWarrior's mobile diagnostic decoder tool and preventative maintenance tips can help us lower our operating costs. Take it away, Dave.
All right, perfect. Well, thanks, Linda and Bob, for inviting me to KIRKS' inaugural Toolbox webinar. And thanks to everybody participating and taking the time today. So with that being said, we'll get started. And as Linda mentioned, we'll save questions for the end. And if there's any technical issues, just put on the chat, and then Linda and Abby can help you with that. So I'll start off just by reviewing the terminology, what we're going to be talking about. Obviously, we have the diesel oxidation catalyst, the DOC, the DPF, the diesel particulate filter. We're going to talk a little bit about review the SCR, selective catalytic reduction system, DEF fluid, diesel exhaust fluid, which is required to help reduce NOx through the SCR catalyst, and then talk a little bit about the EGR, exhaust gas recirculation, which is an in-engine strategy to help reduce NOx as well. And now this is just a simple schematic that's going to open up to review all the major components that we're going to talk about. So as mentioned, we have the DOC, the DPF, and the SCR. So it started off in 2007. There was Gen 1. You'd have a DOC and a DPF, and then in 2010, EPA Plus is when we added the SCR on most models. Now we're going to talk obviously about the DPF. How does it fail? How do I clean it? Pretty evident to examine that. Some simple tools off the shelf. Don't need really sophisticated equipment to tell when that DPF has failed. So we're going to review and have some pictures looking at that. But more importantly, I'm going to focus on the DOC because the DPF gets a bad rap. It's usually why the bus or the vehicle is brought in because it's cracked and failed, and then most attention is focused on the DPF, but really that DOC is responsible for helping keep that filter clean. I use the analogy like the filter's like a big garbage can. It traps and blocks all that soot, but the DOC is like the garbage man. It uses passive and active regeneration to help keep that filter clean. And we're going to talk a little bit, like I said, pretty easy to identify when the DPF has failed, but the DOC is a little more problematic. And there's still, even though the after treatment's been around for quite a number of years now, there's still some, I guarantee a lot of fleets running around with DOCs that are past their best before date and just help diagnose and troubleshoot when that DOC needs replacing, and basically look at how the DOC is performing to give us those signs and signals, and look at some data to understand when that DOC's been replaced, because any cleaner really can't tell you when the DOC is good or bad. The DOC, by the way it's behaving, can tell you that. Then we have the HC doser, which is basically used for active regeneration. The EGR coolers were an in-cylinder strategy to reduce NOx. And when those fail, we have to be cognizant of that, because when coolant leaks into the exhaust, it is detrimental to the after treatment system. Then, as we said, if we get to 2010 and plus, we have a SCR, and you'll know you have an SCR system if you have DEF fluid. If you have DEF fluid on your vehicle, you have an SCR. And we're going to talk about some of the common problems and tips and tricks on how to keep the SCR up and running. So with that being said, I'm just going to proceed to talk about types of regeneration, which is a very important concept to understand, and how it relates to help identify when that DOC has failed. So we have two main types of regeneration on vehicles with after treatment systems. You have passive regeneration, which I like to call free regeneration. It is duty cycle dependent. So you do need sufficient temperatures and duty cycle in order to get that accomplished. And then you have active regeneration, which I call paid regeneration, because it's the backup system. Now, with transit buses, it is because there can be a lot of idling and stop and go. It can really strain the system. So the passive regeneration may not be always working, especially during rush hour. If it's stuck in traffic, you may have to rely on the active regeneration component. So ideally, you want to be passively regenerating your filter. So the bus is going down the road, it's full of people, got a good load, so you got a good high exhaust gas temperature, and then the DOC will help the passive regeneration, because there's NOx coming out of the engine, and the DOC with its chemical coating is NOx comes out primarily 90% NO and 10% NO2, and basically that what the DOC does with its chemical coating, it's going to inverse that relationship and create like 90% NO2. And why is that important? Because NO2 is like a super oxidizer. It's like putting lighter fluid when you're starting your barbecue, and it really helps passively regenerate that filter. But you do need a baseline temperature to get that accomplished. So with a healthy DOC and a good duty cycle, your vehicle should be passively regenerating. And that's the primary source of regeneration. Unfortunately, it's not a perfect world out there. You got, stop and go traffic, maybe excessive idling when the bus is waiting at a station to pick up more passengers or whatever the case may be. And when the temperature is too low and there's not enough duty cycle there, the soot filter is like a garbage can. So it has what we call soot loading capacity. So it's going to store the soot and store the soot and store the soot and store the soot. Eventually, the back pressure is going to get critical. There's a back pressure sensor that's going to talk to the ECM, and it's going to trigger what we call an active regeneration event. So then that's depending on the engine. If it's a smaller engine, it'll be the in-cylinder injectors off cycle. Raw diesel fuel will come down, and the DOC acts like your spark plug. Boom, it'll ignite that fuel. And on larger engines, it has that seventh injector or hydrocarbon doser to ignite that. And I call that paid regeneration, because now we're artificially raising the temperatures by burning extra diesel fuel. And on some transit buses, because they have such stop and go and problems with the duty cycle, some of them are programmed to actively regenerate every 24-hour period. And some of them are done based on pressure. So depending on which vehicle you have, you can tell by downloading on the ECM and look at your regen history, which would be very important when you're determining the health of your DOC, because you want to see how it behaves. So those two concepts, without getting too complicated, active regeneration is your backup system, and passive regeneration is the system designed to be the primary source of regeneration. And when the systems get into issues, when the active regeneration starts to become the primary source of regeneration on the vehicle, that's usually a telltale sign that either maybe the filter needs to be cleaned, or you have some other upstream issues, or possibly a failing and poisoned DOC that's not properly supporting passive regeneration. And I'll come back to that concept when we're talking about how to troubleshoot and identify when the DOC needs to be replaced. With that being said, with DOC substrates, there are two main types. There's corduroy, which is the technical term for ceramic, and there's metallic substrates. So corduroy substrates are less expensive, but not as durable, and not as not as high of a performer. The metallic substrates are a performance catalyst. So if you talk to anybody in the catalyst industry, really metallic substrates are superior. 10 times mechanical shock resistance, less back pressure. They're a better conductor of heat, so they get to operating temperature faster. So if you look at every major category, metallic substrates are superior in every way. The one downside is cost. They are a little bit more expensive to manufacture. So typically the predominant one you'll see out there is a ceramic catalyst. At RoadWarrior and some other manufacturers do offer metallic, so you are getting a superior product as a result, as far as being able to support passive regeneration a little bit more efficiently. Again, it's not a silver bullet. If you put a metallic DOC into a bad situation, it is not bulletproof. If you oil soak it, it's still susceptible to poisoning and other things, but it does have some durability and performance benefits over their ceramic counterpart. So when you're buying, if you're getting a metallic DOC, you are getting a superior product versus their corduroy counterparts. So as mentioned, the DOC, it's the backbone of that DPF performance. The DPF I would call like it's a big garbage can. It traps and blocks all that soot, but that DOC supports that passive and active regeneration. So if you have a healthy DOC, you're going to burn less fuel and it'll report proper regen efficiency. And the biggest problem is, we're going to talk about the DPF later because it's downstream. We'll have some pictures, but when do I need to replace my DOC? And a lot of times you send it to I hear customers say, "Oh, I sent my DOC off to the cleaner and it passed. It's clean certified." Well, there's no DPF cleaner that can tell you if the chemical coating on a DOC is still chemically active. That's the problem. So there's a lot of false sense of security out there. The only thing they can tell you when it's obviously damaged, as I switch to the next slide here, you can see in the picture in the top right, if there's a hole blown through the clear of it, or that's obvious signs of damage. So if your DOC is in that state, you don't have to be a well-trained technician. You can tell that the DOC needs to be replaced. Or if you see signs of what we call face plugging, the DOC should never need to be cleaned outside of maybe lightly blown out. If it's ever oil soaked or completely contaminated, I would encourage you to replace at that point, because if you clean it out, I've had some cleaners kind of say, "Oh wow, it was really oil soaked. I had to put it in the oven 3 times. I almost caught fire, but I was able to get that DOC cleaned." And I say, well, you really didn't do yourself or your customer. You did them a disservice, because essentially you cleaned a product that essentially was probably needing to be replaced, because if it was severely oil soaked, it'd be a prime example of when it would be poisoned beyond useful life. And then probably if you were to install it back into the vehicle, you'd be having regen issues, and that would be a telltale sign. So you want to look for signs of incomplete combustion. As I mentioned, if you get this face plugging, you want to check for exhaust leak, bad in-cylinder injectors, and other issues upstream, maybe a failing turbo. So look for obvious signs for it to be replaced at face plugging. And another important thing is, if you're having regen issues on your vehicle, all of a sudden it's regenerating more than normal, you also want to look at the service history. So if you ever had EGR coolant leaks, blown turbos that leaked oil, or bad in-cylinder injectors because you get a hydrocarbon poisoning, those are all precursors to poisoning a DOC. And I'm not saying every time you have a small coolant leak or you blow a turbo that your DOC has to be replaced. What has happened is your DOC has been compromised and weakened, and hasn't been weakened beyond useful life. And there's a couple ways we can help determine that. Now, the one test that's done quite commonly and is pretty standard protocol is, say that the vehicle came in, the DPF was cracked, so they replaced that. The DOC was cleaned, they got clean certified, they installed it back in. And what a techs will do is, with their laptop, they'll do what's called a forced regen test. And what they're doing is they're looking for temperature rise, a delta T between the temperature 1 sensor and the temperature 2 sensor across the DOC. So when they put it through a forced regen with the laptop, it'll go to high idle, the raw diesel fuel will come downstream, it'll get to light off temperature, which is typically 450 to 500 degrees Fahrenheit. The DOC will act like a spark plug, ignite that fuel, and you want to see about a 400 to 500 degree temperature rise across the callus. And that's telling you that your DOC is not dead on arrival. If you have no temperature rise during a forced regen, and you check that there is fuel being sprayed and it's calibrated properly, you get the right amount of fuel and it's not lighting off, then you know your DOC is DOA, dead on arrival, and you need to replace it. The problem is, when a DOC gets weak in the knees, it's telling you a lot more signs and going to give you a lot more problems. So we want to, if you know your DOC is on its way out, you want to catch it in advance before that quote unquote catastrophic failure. So temperature rise is confirming that your active regeneration works. It's like making sure your e-brake works. I know, well, my e-brake is working, my backup system is working, but we want to know, is that passive regeneration working properly, because that's the primary source. So the good news is the ECM records every active regeneration event, whether it's operator generated by a tech with a laptop. Some vehicles have a button, you can manually do it, or if it's done automatically through the ECM, it'll record that event. So what you need to do is you need to get a baseline, because you need to know what's normal before you know when the DOC is not performing as it should be. So we had a fleet that did this, and they knew, based on the way they use their vehicles, they did one regeneration every 200 hours. So they had a baseline. They said transit buses could be a lot more frequent than that. Some of them can go as often as once every 24 hours, but it's always going to go from what the baseline is. It's going to go from that to worse. So we'll stick with the 200-hour example that I talked about. They had issues with their filter. They brought it in. Filter was replaced. DOC was clean certified. They put it back in. Then they said to me, you know what, Dave, all of a sudden, now the truck's regenerating like 20 to 30 times every 200 hours. And I said, okay, what did you guys do? They said, well, we took the DOC, cleaned it and put it back in. And they were having the same problem. And I said, well, look back. Did it have a turbo failure, coolant leak, or bad install in their injector? Sure enough, they said, yeah, the turbo blew 6 months ago, and it's still having regen issues. So I said they were doing everything perfectly except replacing that DOC, because that DOC, by regenerating 20, 30 times more than normal, and you had a turbo failure pre-existing condition, that's a DOC waving the white flag saying, hey, I'm poisoned. I'm trying to keep you on the road with active regeneration, but it's beyond its useful life because that passive regeneration isn't working like it's supposed to. So that's a very important concept. Hope I explained that without getting too technical. So with the example of a transit bus, if it's regenerating once every 24 hours, then it'll go to multiple times a day. It'll go to 2 or 3 or 4 times a day every few hours. And that's when the DOC is really getting weak in the needs and needs to be replaced. And if you do that, you'll stay ahead of the curve and you will prevent a lot of catastrophic and unwanted failures of that DPF. Because if you put a brand new DPF with a DOC that's been failing, you risk damaging a perfectly new filter. And we've had those issues happen time and time again. Now we're just going to talk about the diesel particulate filters. They are coated as well to enhance passive regeneration, but the bulk of that passive regeneration is done through the catalyst coating. New DPFs definitely provide better value over the reman or recore units, which I would discourage. These things this technology is definitely expensive, so I do encourage cleaning, but I encourage cleaning your own units. Don't exchange it for a reman or a recore product because you don't know what you're getting. You could be inheriting somebody else's problems. I'm a proponent of having spare swing units. This way you can track and trace how many times they've been cleaned, mileage, and then you know, oh, this filter and this DOC just came out of a turbo failure. I got to keep an eye on that after it gets cleaned. Do I have any regen issues? And you can identify and keep that part of your maintenance records. As soon as you buy a reman product, you might as well throw your records out the window because you could have a filter that has 2,000 miles on it or X amount of hours, and you could be getting one that could be 10 times older than one you just gave up. You just don't know. The one nice thing about being able to cross-reference the product for aftermarket, the OEMs do have part numbers engraved on the cans. There's a Cummins example and a Detroit, a Volvo example there. So with Cummins, you want to look for that CPN part number. That's the dealer part number on the little picture in the corner. Is that 2871581 would be the cross reference to find that proper DPF. And then on the other example, it's a name tag. That 223-42601 number would be the Volvo number as an example of a cross reference to find the right aftermarket replacement for it. Or even if you want to just order the OEM product, that's how you know what product you need to reorder. And then how does a DPF look? So I talked about there being different DOCs, where there's also different DPFs. There's cordierite, and then Cummins has come out with silicon carbide. The way you can tell the difference is the cordierite is the one on the left. It looks like that off-white, and then the silicon carbide looks like black checkers all glued together. So Cummins did move to that, and this is where you want to make sure that your aftermarket supplier is supplying with an equivalent product. Some manufacturers are substituting cordierite when the OEM manufactures silicon carbide, and there are some performance differences between the two. So there's different light-off temperatures and soot loading capacity that you would have. So you want to make sure you're getting the exact fit OEM filter. And the other thing that you want to do is when you're looking at the filter, there's the clean end and the dirty end. The dirty end's the engine side. Obviously, it should look all black, like somebody took charcoal and roll over the front of it. The outlet side should look, like the day you bought it. On the silicon carbide, a little harder to identify soot bypass, but on the cordierite, if you see any signs of a soot bypass black and the filter's cracked, it needs to be replaced. And we'll talk about some other visual cues you can look at to determine if the filter's been compromised or cracked by some visual inspection. So why does a DPF fail and why does it need to be cleaned? We talked about the filter constantly regenerating all the time. So that regeneration is the carbon is being oxidized, is a fancy way of saying it's burning off as CO2. So that's how it's self-cleaning during the regen process. But there is ash from lube oil consumption that does build up in the filter. So you have that soot loading capacity. But if that soot loading capacity starts getting taken up by the ash, which is non-combustible, looks like a white powder, so it doesn't oxidize or burn off, so that has to be physically removed. So sometimes if your vehicle is regenerating more than normal, I'd suggest maybe look at your cleaning history. If the filter's never been cleaned, maybe the soot loading capacity is diminished because the filter's full of ash, and the only way to do that is to physically remove it. There's a variety of ways to do that, but you'd want to have that serviced properly by an authorized cleaning facility. And also, as the ash starts to accumulate, you start increasing the back pressure, more fuel consumption, and more active regens. So you're going to be putting more back pressure on the system, which constrain things like turbos as well. So you want to make sure that you're staying ahead of the DPF cleaning maintenance and following those OEM guidelines to clean them as recommended. So I talked about how to evaluate a filter. There's a lot of fancy tools out there, but really you can use stuff that's readily available. So first thing, like I mentioned, you start with a visual inspection. Look for any signs of soot loading. Look for any signs of face plugging or accumulation of soot on the inlet face. That's a sign of incomplete combustion. So you want to investigate if you got an exhaust leak, failing turbo or injector. But it should just look uniformly black without any face plugging. Next, you want to do a pin gauge test. So this will tell you, you take some, it's basically welding wire, about 32 thousandths of an inch thick, and you can sort of see how dirty your filter is. So before you send out for cleaning, you do a few quadrants. Say it's a 12-inch long filter. You put down the wires. You measure. Oh, it's about 6 inches. So 6 inches was dirty, full of ash and soot. You send it out to be cleaned, and you should pin gauge it when you get back. And then you should see that pin gauge go almost next down to the bottom. There are some plugs there, so it should go about 11.5 to 11.75 of an inch down the filter. And if you're doing the pin gauge, if you see a little, turn on the back end. I said, I'm not sure if that's dirty fingerprints or if that's, a crack. If the pin gauge is a hard stop, that usually the cells, when they shift, they crack and the pin gauge won't go through. That's a sign that you got an internal crack as well. And the last thing that you can do, which would be really helpful when it comes to those silicon carbide filters, is do a high lumen light test. Get yourself a strong flashlight, put it on one end of the filter, and then just move your head side to side. Sometimes you'll get a little bit of a glow. That's just the light passing through the plugs. But if you see a white light passing right through, that's another sign of internal crack. So the DPFs, you can visually inspect them before and after cleaning. 2 reasons: you want to make sure you're not sending out a cracked filter, because if it's cracked, you might as well just get it replaced. And once you get it back from the cleaner, you can ensure that with the pin gauge that they've done a good job cleaning it and they haven't damaged it in the process as well. So you should do that visual pin gauge testing and the high lumen test before and after a DPF is sent out for cleaning upon return, so you can confirm that you don't have a compromised filter. Now, there's different cleaning options out there as well. Again, I'm a proponent of cleaning. There's air cleaning and liquid-based cleaning. Both have their pros and cons. The air cleaning, if it's used properly, I usually recommend that you use the thermal treatment as well. So every should be air cleaned, thermally treated, and air cleaned again. It's not that the air cleaning is bad. It's just the difference between clean and deep clean, because there's always some degree of what we call sintered and impacted ash and soot. And that's just a fancy way of saying, boy, that soot is really caked and glued in there. It doesn't matter how much air you get. And when you put it in the oven, that thermal treatment will help oxidize some of those binding constituents and get that filter clean. Because I know a lot of companies use these flow benches. And once you get that filter, say 80% of the way clean, it really doesn't detect that sort of taking it all the way. And I told the guy, hey, even if it flows green on your test bench, put it in the oven, dirty side down, call me the next day. And they say, hey, you know what, Dave, you're right. I put the dirty side down on my oven and still some more ash and soot just fell out after the oxidation process. So it's not that air cleaning is bad. It's just air cleaning and thermal treatment is the difference between clean and deep clean. And the liquid-based cleaners, if you have somebody who's using that, a good alternative as well. The advantage there is they're able to get that cleaning done at less time frame, because if you're using the traditional cleaning, you're going to need an overnight baking process, whereas the liquid and ultrasonic guys will be able to accomplish that in a short amount of time. But sometimes there's price differences. I'm a supporter of both, as long as they're both used properly and you're using a reputable partner to clean and test your filters and catalysts. So here's some pictures to say, how do I know when a filter's failed? Again, here's an example of, you can see the outlet side, it's stained with soot stains, so we know the filter's cracked. but you see some staining. Here you see some green staining. It looks like it could be coolant. The other one you see some staining. Is that oil? Is it just moisture? We don't know. So anytime you see any signs of staining, you want to think about the DOC. Was it because if the filter is exposed to coolant, oil, or hydrocarbon poisoning, so is the DOC as well. You can use your software, and we have a diesel decoder tool I'll be talking about to look for fault codes, look for engine history of excessive idling, signs of oil contamination, coolant consumption. And if you have history of blown turbo, EGR, or coolant leaks or bad in cylinder injectors, you definitely want to do that DOC test. So don't let me tell you if the DOC is good or bad, or the OEM. Let the DOC tell you how it is by the way it's behaving. So look at its regen history. Not only do that temperature rise test, but look at the regen history. If once you have that baseline, if it's doing it, 2, 3, 4, or 10 times more than normal, that's usually a sign that the DOC needs to be replaced, especially when it's combined with pre-existing failures, as I mentioned before. So here's another example of what happens on the inside of the filter. This is we did destructive analysis on a filter. You can see this is telltale, what we call uncontrolled regeneration. What happens is the filter becomes overwhelmed with soot. It's not regenerating properly. Maybe the DOC is a little weak, or there's too much fuel being injected downstream. All that soot is fuel. Then the driver's putting his foot on the gas to get more power, and then you get it critical. All that soot, some raw unspent diesel fuel, and then it's going to go to what's called uncontrolled regeneration and literally burn it from the inside out. Even though the face of the filter may be intact, you can see the internals have been completely destroyed. And this was an example of a transit authority that was working with us and said, "Hey, you know what? Your filters, they're failing on us. We have a problem." And I said, "Well, it's funny you mentioned that. You bought like a bunch of DPS, but you haven't bought a single DOC. Let's bring some of these filters back. We're going to do a destructive analysis." So we did this, and we found textbook uncontrolled regeneration was not a manufacturing defect, but obviously an operational issue. Then we asked them for the OEM filters. It was ended up being some Cummins DOCs. We sent them off to third-party elemental analysis. That's the only true way you're going to determine the state of a DOC. Those tests are extremely expensive and time consuming, but sure enough, the DOCs came back and they're all dead on arrival. So we educated the transit authority to start monitoring their regen history and look for signs of pre-existing conditions. They started buying some replacement DOCs, and sure enough, now our filters were lasting and performing much better. And I told them, I said, "Hey, the Cummins filters were failings too. So obviously you had a problem, and the root cause of the problem, there's nothing wrong with the RoadWarrior filters or the OEM filters. The problem was the DOCs weren't supporting the regeneration properly, and we're having uncontrolled regens destroying perfectly good filters." So this is something that we want to look at. Look for those fault codes, signs of the contamination, excessive active DPF regeneration. And so look at that, do that DOC test. Look for the temperature rise, but also your regen history. Those two things together are going to tell you the state of the DOC and when it needs to be replaced. So that's probably the biggest takeaway I would want everybody to have when they're looking at taking care of their after treatment system. The other thing that I want to mention, I know some of the OEMs like Cummins got rid of their reman program, so I would encourage everybody to recycle their scrap DPFs and DOCs, turn your garbage into cash. We partnered with a company called Cat Rebates, but we don't have any skin in the game. We just partnered with them because we found they gave the most value, most bang for the buck to our customers. But I'd encourage you, just look for a recycler and turn your garbage into cash. And we've had a lot of customers that have gotten hundreds or thousands of dollars in return, and they're very pleased and happy. So two things: you get money back so you can invest that into a replacement product, and you're environmentally disposing these properly, keeping them out of the landfill and making sure they're recycled and everything's recycled and disposed of properly. So talking about the SCR is a very efficient system, but has a very narrow operating window. So this is some pictures here, especially that one picture in the top left. I call that an SCR having a heart attack. It's what we call a death fluid crystallization. So that happens because the amount of death fluid that has to be sprayed has to be very precise. You have to have enough to convert the NOx, but not too much, because if you spray too much and it's not being consumed, when the water evaporates, the urea left over is going to crystallize, and you see that on the DEF dosers and in that mixing chamber over there. So again, death fluid crystallization is enemy number one. First thing you want to do is people don't realize that DEF fluid does expire. So it has about a 1-year shelf life. So you want to, if you are ordering, you want to make sure you're rotating and making sure that you're using DEF fluid that's within its expiry date. If you're buying it in large drums or tanks, if it's out by the back roll-up door in the summertime, exposed to heat and high humidity, the shelf life can reduce from 1 year down to 6 months. So if you are buying it in bulk, you want to make sure you're buying it in large quantities, but you're consuming it on a regular basis. You're not buying like a 6-month supply all at once, because you're probably risk getting some expired DEF fluid and getting DEF fluid crystallization unnecessarily. And then you also want to visually inspect. So here we're looking at the DEF dosers. You can see crystallization on the nozzles. There are some things where you could try to clean those DEF dosers. I've talked to most techs, once it's been crystallized, if you clean them, they tend to fail pretty quickly. So based on the cost, most techs, when they see crystallization, they'll just go ahead and replace those DEF dosers. That little instrument on the bottom is a refractometer. Just like you can test coolant for low temperature performance, you can test your DEF fluid. You want that 32.5% concentration of urea, so you can make sure that your DEF fluid hasn't been compromised and degrading and avoid crystallization. So we look for signs of crystallization, make sure our DEF fluid isn't expired. We can do a DEF fluid test with a refractometer. The other thing that fails is exhaust leaks. And exhaust leak wreaks havoc not only with crystallization, but also can give you false back pressure warnings as well. So if you don't have one of those smoke machines, I'm a big proponent of those smoke machines that can help you identify an exhaust leak. Probably the most inexpensive fix you can have. A new clamp and gasket set or replacement bellow can go a long way. And then the last thing is the NOx sensors. NOx sensors fail because NOx sensors are providing negative feedback to the ECM. So if the NOx conversion efficiency starts to drop, it's going to say, hey, spray more DEF fluid. If it starts to get too high, they say, hey, back off a little bit. But if that NOx sensor gets out of whack, you can overspray or underspray DEF fluid and cause yourself a crystallization issue. So those are the things you want to look at, those handful of things. And if you go through all those handful of things I talked about and you're still having NOx conversion issues, then it's probably the SCR itself that needs to be replaced. But you want to look at those inexpensive fixes before you get into pointing your finger to the SCR. And more importantly, that's why that DPF filter, you want to make sure when it gets compromised or cracked, you want to replace it, because it's in front of the SCR, and it acts not only as a barrier to trap soot, but also prevents all those contaminants from flowing downstream, and you'll get a domino effect. As that filter fails, you can wipe out a very expensive SCR system. So that's something you want to keep an eye on as well. And like I said, if you see black smoke coming out of your exhaust stack, that's a telltale sign. You don't have to turn a wrench, and you have a filter that is compromised and most likely needs to be replaced. And you want to inspect if you have any other upstream issues going on. So I'm just going to review some what I call fleet triage that you can do. It's probably a good idea to get somebody to take the lead on the after treatment system on some of the things that we can do to help troubleshoot. So what do we want to do? Again, you want to have somebody probably take the lead, but what's really important is to understand your regen history and your forest regen history. So the nice thing is that ECM does record that. So you want to download your regen history and have a number of breakdowns. How many regens do I do per 100 or 200 hours, or how many regens do I do per day or per week? You have a sort of a normal baseline. So then what's normal for when it's always going to go from, even if you have a truck or bus that you haven't done this from the beginning, you're going to see the problematic vehicles versus the vehicles that are performing as expected. So you also want to look at your back pressure readings during a first regen to get a snapshot to make sure if you see the back pressure really through the roof, then you know that maybe the filter's completely plugged or you got some other issues going on. So you want to look for excessive back pressure out of range during a regen. That filter's probably extremely plugged up, could be completely face plugged, and you risk blowing that wide open. So we want to avoid that. We can do voltage testing for temperature sensors and NOx sensors as well. Look for exhaust leaks. Like I said, doing a smoke test. There was one school bus. I just happened to be there. It was at the OEM. It was having all kinds of issues. Only had a couple thousand miles on it. They looked for visibly, they had it up and they were looking for exhaust leaks, but it ended up being on the belly side. And the tech just said, hey, I got the new smoke machine, let me just hook it up. And sure enough, it was showing an exhaust leak. They just replaced the clamps and gaskets, and all the regen issues and problems with the aftertreatment system went away. So looking for exhaust leaks is very key. And then problem vehicles will review that poor regen performance. So if you're having more regens than normal, or the driver say, hey, this bus does have a lot of power, it's trying to regen all the time, you want to say, hey, when was the last time I cleaned my filter? If it was done recently, then you want to look for blown turbo, coolant leaks, or bad in-cylinder injector repairs. That combined with a poor regen history, that's the DOC telling you that it needs to be replaced. So if you do that, you'll basically stay ahead of the curve, and you'll keep more uptime and avoid potentially recurring DPF failures and uncontrolled regeneration issues. So I call there's some cold engine inspections that you can do. So the visual inspections you could do is look at your DEF injectors, look for signs of crystallization, and look at that mixing chamber to see if your SCR is having a heart attack. If you see signs of crystallization, you want to look to see if your DEF fluid's okay. Do I have any contamination? Do I have exhaust leaks? Are my NOx sensors working properly, etc.? And you want to try to find the root cause. So whenever something goes wrong with the after treatment system, whether it be NOx conversion issues or DPF has failed, you want to ask why, and you want to make sure you put on your detective cap and find that you truly get that root cause. Because if you don't find the root cause, you're going to have recurring issues, and then spending good money after bad without fixing the root cause of the problem. The refractometer can test that DEF quality. Again, history of EGR coolant or EGR cooler or coolant leaks, turbo failures, injector history as well. And if the DOE has not been replaced, look into replacing that. Another thing that's very useful is I know a lot of companies, engine oil analysis is great, because you can look for signs of contamination in the oil. If you see things like calcium or sulfur or some other phosphorus in the oil, that'll basically lead to DOC poisoning. So especially when, if a guy is putting jug after jug into his radiator, by then the leak has probably started off small, it's been going on for months. If you're doing the engine oil analysis, you'll catch signs of that contamination in the engine oil analysis and stay ahead of the curve. Fix that leak before it totally wipes out your DOC and your after treatment system. Visually inspect your delta P sensors. It is a pressure transducer with tubing, so you want to make sure that tubing is not leaked or crimped. If it's crimped, you can get a false high back pressure warning on it. DEF fluid filters. There's oil filters, air filters, but there's also DEF fluid filters. Some people are not used to looking for that, so make sure the DEF fluid filters are changed when they're supposed to. And again, the tailpipe. If your exhaust stack is black, your filter's cracked. So you don't even have to have the vehicle running. If you see black smoke of the exhaust, then the filter needs to be inspected. Then what I suggest companies do is you clean out that exhaust stack, so if it comes back down the road, it wasn't from a pre-existing failure, it's something that's new. And then you also want to review and investigate any fault codes. And we have the diesel decoder tool that I'll talk about in a couple slides. And finally, so after you fix your repair all findings and you look for any upstream issues, it's good to assign a team lead, a go-to person that's going to take charge of the program. Some guys have told me, man, I can barely track when to change oil and these things. How am I going to record all that? Well, if you don't take the time to understand what's normal for your vehicles, then you're not going to be able to repair them properly. So really having the trained staff and getting them the right tools and the software so they can record those, look at that regen history and track and trace all that. And then the data is going to jump off at you at the screen. You're going to see that and see the problem vehicles versus the ones that are performing as expected. So you want to basically make sure you definitely investigate the after treatment system. Again, I sound like a broken record with EGR failures, turbos, and bad in-cylinder injectors. What impact it have on the after treatment system? And always use brand new units, whether it be OEM or aftermarket. I discourage reman units because those are essentially using clean filters, so you could be inheriting somebody else's problem. And if you put this triage inspection into place, you'll maximize your cost savings, repair it right the first time, and keep the vehicles on the road and maximize your uptime. So just quickly, this diesel decoder tool is something that we have. We partner with Diesel Laptops. It's a web-based application you can buy. Basically turns your cell phone or your or your tablet into a diagnostic scan tool, there's a diesel decoder app that you download from either Apple Store or Android, and allows users to clear and view fault codes in the palm of your hands. Now, it retails for $350, so don't want to overrepresent what it's going to do. It's not going to replace a full laptop system, but it is pretty powerful, especially I've had some customers say, hey, I can equip my mobile techs. If I have my laptop system tied up in the shop, I can get him a decoder. He can go out, plug in, and at least read the codes and see what's going on, and then maybe bring it back or bring the laptop out. And the other thing that's pretty powerful with the decoder tool, it does have some bidirectional commands. So one of the things that it can do is it can do forced regens through the app, which is a game changer. Also resetting the ash counter. So the freemium version of the diesel decoder will allow you to view and clear soft fault codes. Right now, the bidirectional regen is included free in the app. That will become a pay-per-use down the road. And also, you can do things like resetting the DPF ash counter and some pretty powerful bidirectional commands in the palm of your hands. And that forced regen, you shouldn't be forced regenning it all the time. If the vehicle's asking for a regen, that usually means there's a problem. So you basically, the idea is to regen it remotely, and just saves you that hook or that heavy tow belt, but get it back to the shop and investigate, and it should be repaired properly to avoid any progressive damage on the vehicle. So just wrapping it up. So, RoadWarrior with KIRKS has you covered. We're the industry leader with the most DPF DOCs and SCR in the marketplace. When it comes to heavy duty trucking side, we got the Detroit Diesel 1 boxes and the Volvo 1 box design. We're getting into that, but have the filters for it. Over 1,000 OEM part number cross references. The largest inventory and distribution network in North America. We do manufacture those premium metal core callus technology, which is you're getting a premium product versus the OEM. We have NOx sensors and depth filters available as well. Lithium, lightning volt lithium battery technology, which is more specific to electric APUs and not really for starting batteries for transit applications. And we do have that diesel decoder tool. If you're interested in that, be happy to answer questions at the end, or if you can reach out to KIRKS if it's something you feel that you can make use of in your shops or with some of your techs, that'd be great. And we can always have training lunch and learns and other fleet lates like this. And I believe this presentation will be recorded and forwarded afterwards, so it can be circulated to anybody who wasn't able to participate today. And just showing, the distribution network. This map as 12 warehouses. We actually just added a 13th. We just opened up an Albany, New York warehouse, so we'll get this northeast corner covered as well. So if it's in red, means it's within 1 day ground to you. So not only can you order from KIRKS stocks it for our products regularly. We also can drop ship if you're in a hurry, if you're in a different part of the country. You can take advantage of free ground shipping within 1 day from one of our warehouses, and you can leverage that with KIRKS. Either draw from their inventory, or we can drop ship on their behalf and get it to you in an emergency breakdown situation. And we also have, next day air discounted rates. If it's in that 2 foot by 2 foot box, we flat next day air for $175, or free ground shipping on the majority of our products that are under 75 pounds. So that's pretty much it. I want to thank everybody for taking the time today. Hopefully you found some of that information beneficial and helpful. And with that, I'll turn it over to Linda and Bob. If there's any questions that come through, that I'd be more than happy to answer. So thanks again to Bob and Linda for preparing this and inviting me. And if you have any questions, I'd be more than happy to answer them.
Thank you, Dave.
Yeah,
Bob,
thanks a lot, Dave. We really
did you have
appreciate it.
any questions, Bob, that you wanted to run past Dave?
I did not see any questions pop
No,
up yet.
but if you had any questions.
Oh, well, like Dave was saying, for the shipping, if you did need some through their distribution network, obviously, Dave, they can order it straight from KIRKS, and or we can drop ship on our behalf from your different locations also.
Yeah, and KIRKS does have plenty of our product line in stock as well. So you can draw from their inventory, or they can supplement and draw from our distribution network in an emergency situation, and we can definitely drop ship on their behalf right to your door.
Yeah.
Beautiful. Well, if you have any questions, if you're watching the recording, you can always email sales@kirks.com or call KIRKS at 313-933-7030. And as Dave said, the recording of this webinar will be emailed to registrants. It's going to be available on KIRKS YouTube. And we'll also have it available in our KIRKS monthly news. If you're not getting the KIRKS monthly news, then you can head over to the website and sign up. It is something you don't want to miss, once in your inbox every month. And the KIRKS team would also really appreciate your feedback on this webinar. There'll be a 3-question survey. It's anonymous. It'll pop up as soon as we close. And we want to say that we appreciate Dave Jerman and RoadWarrior as our guest. You have provided a wealth of information. I have to say, Dave, you have a great talking speed. It was a lot of good stuff. And we want to thank you, our attendees, for joining RoadWarrior and KIRKS. Remember, KIRKS is your partner for parts. Thank you and have a great day.
Thank you, Linda.
Well, yeah, thanks for everybody for taking the time, and thanks for having me on. Really appreciate everybody's time. Hopefully you found that helpful. And like I said, you have my contact information there. We'd be more than happy to answer any questions. Feel free to reach out to me directly or through KIRKS as well.
Absolutely. Thank you again. Bye-bye.
Thank you.
All right. Thanks, everybody. Take care.